Hello, my name is Neha and we are on problem 2. Today's problem is called valid anagrams and it's one of the most common interview questions. It looks simple, but it's a great test of your understanding of strings and hash maps. So the problem statement here is as follows. Given two strings S and T, return true if the two strings are anagrams of each other. Otherwise, return false. Let's first understand what an anagram is. The two strings are anagrams if they have the same characters with the same frequency, but possibly in a different order. We have two examples here. Example 1 gives two strings S and T, and both have two R's, two A's, two C's, and one E. As we can see here, same characters with same frequency. Therefore, they are anagrams. Also, the recommendation here is to aim for time complexity big O n plus m and space complexity big O of 1, where n and m are the length of string S and T. So to determine if two strings are anagram, we can count the frequency of each character in both strings and then compare frequency maps of the two strings. If they match exactly, we return true. Otherwise, return false. The reason we are using HashMap or dictionaries here is because it allows us to store each character as a key and its count as a value. So let's convert our idea into code. We are using Python here. We will first check if the lengths of S and T are not equal. If they are not the same, they cannot be anagrams. So we simply return false. So our first check is done here. Step 2 will be initializing an empty dictionary called scount. Then for each character in the string S, if the character already exists in our dictionary, we increment its count by 1. Otherwise, we add it to the dictionary with a count of 1. So let's start the dictionary. To check each character of string S, we will need a for loop. For char in S, we'll check if the characters of S already exist in S count. If it does, we will simply increment its count by 1. So if char in S count otherwise scount char equals 1. We'll do the same for the second string T. We initialize another empty dictionary called tcount. Then for each character in T, we will check if the characters exist in dictionary tcount. If it does, we will increment its count by 1. Otherwise, we will set its count to 1 and add that character in the dictionary. And finally, what we are going to do here is we'll compare the two dictionaries and we will return the result. It will be either true or false. Now our code is ready here. Let's run it and check if it passes all the test cases. As you can see, our test cases are passed. Everything looks good here. But if we notice, we are repeating frequency logic twice for both strings. So the pro tip here is, instead of writing the frequency logic twice, let's define a helper function named word count to keep our code clean and reusable. So the helper function called word count, which will accept a parameter n. And then we initialize an empty dictionary named char count. Inside the function, we will then loop through each character of n and check if the character already there in the dictionary. If it does, we will increment its count by 1. And if it doesn't, we will simply add the character with a count of 1, like we did here for each string. So for char in n, if char in char count char plus equals 1. Otherwise, let's comment out the old code. And at last, we will simply return the dictionary here. Now the main function becomes simple and easy to understand. So once the helper function is ready, I will reuse it for both S and T strings. I will compare and return the result. Now finally, we will run this code again and check if the test cases pass. As you can see, we have an error here. Line 25. It says char count is not defined. Okay, there is a mistake, spelling mistake here, the typo. Let's rerun it. As you can see, our test cases are passed now. So this is what we came up with. It's more cleaner and reusable. Also, the time complexity here is big O of n plus m, where n and m are the length of the strings. This is because we loop through each character once for each string. And the space complexity is big O of 1, assuming the input contains only lowercase English letters. Otherwise, it's big O of k, where k is the number of unique characters. And that's problem 2 solved. If you are solving this with me, let's move on to the next one, which is 2-sum. See you in the next video. Bye-bye.